A continuation of our discussions on topology. Like I promised, we are going to present some notations which will require an understanding of charts and atlas. So you are welcome. To begin with, let me, supposing we have a manifold, something like this. Okay, supposing this is a manifold. Now, supposing we pick a point or points, maybe x1 in the manifold, then, I form a neighborhood around this point, okay, points. And suppose I have another point here, let me call it x2. Maybe I have another neighborhood around it, okay. Then these points have a name. We are going to call this coordinate domains. Okay, we call them coordinate domains. That's the name. Or some call them or neighborhoods. Some call them coordinate neighborhoods or coordinate domains in a manifold M. Now, we may now, based on the definition, we may also want to translate these points back onto maybe R2. So this will look like, this one will look like this. So bear a map. So I have a map from this point to this point in R2. This is a typical R2. Then let me call this map, suppose this is X, let me call this N, okay, N of X2, okay, and this, I will now call this N of X1, okay. These are neighborhoods, okay, of points in the manifold. And now translate them to bear a map. Let me call it phi X, okay. So a map phi X to what do you call phi X, okay, of U, so of N X2, okay, of N X2, okay. This is the image. So this is the domain, and this is the image. So phi X produces a map here on the R2, on R2, which we now call phi X of this neighborhood, N of X2. And I have the same, I may repeat the same here for this will be another map. Okay, that may be phi Y. Okay, and it will produce this. This is going to be phi y of n x1. Okay. Okay, then these maps, they have a name. We call them coordinate map. Okay, each one. So this phi x is a coordinate map. Phi y is also a coordinate map. This is our M, the manifold. Okay. And these ones also, their images, which is they produce in R2, also have a name. We call them charts. Okay. So these charts are going to be, so that means the charts are now, the images which are produced was going to be a pair, but the charts are going to be pairs like this. Phi y, or let me even say n of xi under, for example, nx, I want let me be specific, phi x. This pair is what you call the chart. That means the image n of xi of n of xi, x1 under the map phi y produce a chart. Likewise, this one, n of x2, referring to the neighborhood, under phi, this first one is pi y, sorry here, and this is pi x. It's also another chart. Now, if I have the third one, fourth one, and so on, and I may wish to collect them, these are our charts, like these are charts. But if I now collect all of them, okay, all the n of xi and maybe let's say pi I, the collection of all of them, where each x is a point in the manifold. So this is going to collect all of them. And when we collect them, we are going to produce what we call atlas. Okay. The collection of all the charts, n of xi under phi I, where x is a point for all the points in the manifold. So you discover maybe I have x3 here, x4, x5, and so on. If I collect all of the charts for this manifold, I'm going to generate a data which I call atlas. Okay, this looks like, for example, in a map, the charts may represent your cities. Okay, and the atlas may represent the whole state, as the case may be. Or if you are considering a country, the atlas may be a compilation of all the charts of states and so on and so forth. So I welcome you to next presentation where we take some more